Hello everyone, welcome to Physics Ninja. Today we are going to start our first chapter of physics from the syllabus of class 9, which is motion. Let us first go through the table of contents and see what we are going to learn in this chapter. So we'll be starting with the definition of rest and motion. But this rest and motion depends on the observer and their position, right? So we're also going to understand the meaning of frame of reference. We're going to learn about the concepts of scalar and vector. And with this concept on our shoulders, we're going to learn about distance and displacement, speed and velocity, uniform and non-uniform motion, and acceleration. We're also going to understand what circular motion is, and we're going to visualize motion through the eyes of mathematics using graphs and equations. And finally, we'll conclude it with some key points. Let us dig deep into our understanding of motion. Before understanding motion, we need to understand what rest is. So, if a person is, let's say, sitting on a chair, or let's say if a person is lying on a bed, right? So, we can say that the person is at rest. Basically, the person is not changing his position. And so, if we need to write the definition of rest, which by the way is very important from examination point of view, we can write that when the position of an object does not change with respect to the observer, then the object is said to be in rest. Now we can move on to motion. So basically anything which is moving like this car, or let's say if you are walking or running. So all these examples are examples of motion. So if you need to write the definition of motion, we can write that when the position of an object changes with respect to the observer, then the object is said to be in motion. As I mentioned earlier, that motion and rest are based on the perspective of the observer and their position. So what do I mean with this statement? Let me give you an example. Let us say that you are sitting inside a train with your co-passenger, right? So now when you look at your co-passenger, does your co-passenger seem to be moving, or does it seem that his position is changing? No, right? Because according to you, he is at rest. So let this be our example 1. Okay, so let me just change colors real quick. Now in the second example, we'll introduce another person who is standing, but he is outside the train, right? Is standing. Now, according to him, he is at rest and both of you, along with the train, is in motion, right? So, in this case, both you and your co-passenger are in motion. Now, let us introduce a third example where basically you and your co-passenger directly looks at the person who was standing, right? What you will see is that this person is traveling in the opposite direction, or let's say moving in the opposite direction. So according to both of you, this guy is in motion, but according to him, he was standing still, meaning that he was at rest, right? So you see what I did here is that the concept of rest and motion is relative, basically meaning that it depends on the observer and their position. So to classify if an object is at rest or at motion, we need to first set a reference point, a point with which we can compare things. And this reference point is considered to be at rest. Okay. So let's say in the first case, you are the reference point. In the first example where you are looking at your co-passenger, right? Now, in this case, what you do is that you put your co-passenger in an imaginary frame. And what happens inside the frame is that you only focus on him and ignore everything else in the surroundings. This frame with you as the reference point, right, is known as the frame of reference. Now, in the second case, the observer outside, right, he is the reference point, and both of you along with the train is what? The frame of reference. And what happens in the third example? you can either consider you or your co-passenger to be the reference point, right? And this guy here will be inside your frame of reference. Okay, so you see here that the concept of motion and rest is completely dependent upon the reference point and the frame of reference. To one person, something might be in rest, to the other person, it might be in motion. So it completely depends on observer to observer. So now we are going to study about scalar and vector quantities. So scalar quantity refers to any physical quantity with only magnitude and no direction. For example, speed, distance. So we're going to study about speed and distance later in this chapter. For now, it is just important for you to know that speed and distance are just examples of scalar quantities. Now, how do you denote a scalar quantity? It can be denoted with any variable, let's say A, B, C, or anything of your choice, right? To write a scalar quantity, what we do is the scalar quantity has only magnitude. So I'll give you an example. Let's say A is a scalar quantity, or let's consider A as speed. So we'll write this as 60 meter per second, right? So this entire thing is known as magnitude. Remember that it does not have any directional component, okay, which will be there in vector quantity. We will talk about later. So magnitude is basically a numerical value plus some units. Okay, so this is what scalar quantity means. Now, talking about vector quantities. Vector quantities are quantities with both magnitude and direction. Some examples are velocity, displacement. Again, we'll talk about velocity and displacement later in this chapter. Okay, for now, just know that these two are the examples of vector quantities. A vector quantity is denoted by any variable, but the important thing to note that on top of that variable, you need to put an arrow sign. So now this becomes a vector and we call it as A vector. We can also write as B vector, C vector, or basically anything that you want. A vector quantity, let's say velocity, is represented as 60 meter per second x cap, right? So this basically is the magnitude part, as I have shown you in the example of scalar, and this is basically the direction part. So x cap means that the velocity, let's say A is the velocity of a car. So x cap means that the car is moving in x direction. So we have another directions like y cap, z cap, which basically means that the car is moving in y direction or z direction. So now since we have studied about scalar and vector quantities, we'll move on to distance and displacement. Okay. So I will try to explain this topic with the help of an example. Let's say a person is standing at point A and he decides to move to point B, which is, let's say, at a distance of 10 meters from me, right? And then after some time, he decides that from B, he decides to turn back and move to point C, which is somewhere here and at a distance of 5 meters from point B. Okay. Now, if it is asked to calculate the distance, okay, how will we do it? So for that, we need to first know the definition of distance. The complete length of the path between any two points is called distance, meaning that distance is basically the total path length traveled by the person between points A and C. Okay, it is a scalar quantity, meaning it has no direction. Okay, so even if the person has turned back, so it does not matter while we calculate distance, and distance can always only be positive, and it will always be positive. Okay, so how can you calculate the distance now? So distance is the path length between point A to B and B to C. So the path length between A to B is what? 10 meter, and the path length from B to C is what? 5 meter. So the total distance traveled by the person is what? 15 meter. Now, if it is asked that what is the displacement, right? For that we need to know the definition of displacement. Displacement is the shortest or minimum length between the final and the initial points. Basically, for displacement, we only need to know the final point and the initial point, right? It does not depend on the path taken. It is a vector quantity, meaning it has both magnitude and direction. So in this case, we'll consider that from B, it has taken an opposite direction to reach point C, right? We'll consider that because displacement is a vector quantity and displacement can be positive or negative. I'll show you how distance is positive and negative. So to calculate the displacement, so first the person goes from A to B. So let's consider this direction as positive and this direction as negative. Okay. So obviously this is the opposite direction, so it will be negative. So the person goes from A to B first, right? So in the positive direction, so we will write what? 10. Now from B to C, the person comes in opposite direction. So what we'll do? Plus, and this direction will be negative because it is a vector quantity, right? So we need to add the negative part. So that this negative part basically gives us direction, nothing else. Okay. So the displacement will be what? 10 minus 5, which is 5 meter. You see the difference between distance and displacement? Distance is the total part taken, which is what? 15 meter. But displacement is basically how much you have moved from your initial point, which is what? 5 meter. Because the person has stopped in C, he started from A. So the distance between A and C is what? Only 5 meter, which is the displacement, right? So always remember that positive displacement basically means if you see plus 5 meter, so it will basically mean that the person or the object is moving in this direction. And if you see a displacement which is minus 5 meter, meaning that the person has moved in the opposite direction. Okay. So I'll give you another example which is very important. Let's say a person needs to move from point A to point B, which is at a distance of let's say 10 meter. Now, one person goes through this path. Everybody has to reach point B. Okay, just remember that. So one person goes from this path, which is at a length 5 meter. It goes in this direction, then travels this direction, which is what? 10 meter, and then comes back to B with while again traveling 5 meter. One person decides to travel in a straight line from A to B, so he travels a distance of 10 meter. And another person, let's say he takes another path, which is let's say at 20 meter. It is what? 5 meter, and it is another 5 meter. Okay. Now, if we consider the first person who takes this path, what is the total distance traveled by this person? So distance traveled is what? As I told you, the total path length taken by the person. So it will be what? 5 meter plus 10 meter plus 5 meter, which is what? 20 meter. So what is the path length or the distance traveled by this person? So it will be what? 20 meter plus 5 meter plus 5 meter, which is what? 30 meter. And what is the distance traveled by this person? It is just 10 meter, right? So we can see that to reach from point A to point B, a person can take numerous paths, right? And the distance traveled in all those paths are different as well. But the displacement between point A and point B will always be 10 meters, right? So if a person has traveled directly from A to B in a straight line, it means that the distance and displacement of the person is same. But if the person has traveled in this path, then the distance of the person is 20 meter. But the displacement will always be 10 meter because displacement does not depend on the path. It just depends on the final position and the initial position, right? Similarly, if the person takes this path, the distance will be 30 meter, but the displacement will be same, which is 10 meter. So what do we conclude here? that the displacement between 2 points will always be constant, but the distance is not necessarily constant. Okay. And also from this we derive a very important observation, is that distance is always greater than or equal to displacement. Always remember this, and this is one of the most important concepts in motion. Okay. If you see the two examples, you can see that either distance is equal to displacement, okay, or the distance is greater than displacement. In this example, if you can see that 15 meter is greater than 5 meter, obviously the distance is greater than displacement. Similarly, in this case, you have 20-meter distance but 10-meter displacement, so the distance is greater. In this case, you have 30-meter distance but 10-meter displacement, so obviously the distance is greater. And in this case, the distance and the displacement both are 10 meters, so distance is equal to displacement. Okay, so always remember this, that the distance is greater than or equal to displacement. So let us quickly try to solve a numerical so that you can understand the concepts better. Okay, so the question goes like, an athlete completes one round of a circular track of diameter 200 meter. So basically the diameter of this entire circle is what? 200 meter, meaning that the radius is 100 meter, right? Okay, in 40 seconds. So the time given is what? 40 seconds. What will be the distance covered and the displacement at the end of 2 minutes 20 seconds? So the first and foremost thing to be done here is always consider SI units for any numerical. Okay, so in this numerical, it is given 2 minutes and 21 seconds. But always remember that the SI unit of time is second. Okay, and the SI unit of length is meter. So in this case, the length is given as meter, which is okay, but the time is given in minutes. So we need to convert it in the SI unit. SI unit is basically an international system of units. Okay. So we know that 1 minute is equal to 60 seconds. So 2 minute is basically what? 120 seconds, and 2 minute and 20 seconds means 140 seconds, right? It's 120 plus 20, so 140 seconds. So the total time, total distance covered and the displacement after 140 seconds is, now since the athlete is covering a circular track, so its track length will be equal to the circumference of the circle. So what will be the distance traveled in 40 seconds? Like, because it is told that in one round, to for the athlete to complete one round, it takes 40 seconds. Okay, so in 40 seconds, what is the distance covered? Which is equal to 2 pi r, which is nothing but 2 into 3.14 into r, which is what? 100 meters. Okay, so the answer comes out to be around 628 meter, right? Okay, so this is the distance traveled in 40 seconds. Now what is the distance traveled in 1 second? In 1 second, the distance traveled will be what? 628 divided by 40, which is what? 15.7 meter. So basically in 140 seconds, what will be the distance traveled? It's 140 into 15.7, which is almost equal to 2198 meter. So this here is the total distance traveled in 140 seconds, or you can say 2 minutes 20 seconds. Now the tricky part comes here, where you are asked to find the displacement. So here's the trick here. Let's say the athlete starts from here, and in 40 seconds, in the first 40 seconds, he moves all the way through this circular track and reaches at this point. So after 40 seconds, the initial and final position of the athlete is same, meaning that the displacement after 40 seconds is what? 0, right? Now, after another 40 seconds, now the total time has passed is 80 seconds, right? Another 40 seconds, the displacement is still 0. Again, after 40 seconds, which is a total of 120 seconds now, the displacement is still 0. But now, in the next 20 seconds, the athlete goes from here and reaches here, right? Now, as I told you, the definition of displacement, the displacement is the shortest distance between the final point and the initial point. So, what is the direct shortest distance between the final point and the initial point? It is obviously the straight line distance, right? So, the straight line distance is what? 200 meter, which is what? The displacement after 140 seconds is what? Just 200 meter. So I hope you have understood the question very well, because this was quite a tricky question. So using the concept of distance and displacement, we are now going to learn about speed and velocity. So let us first start with the definition of speed. Speed is the rate of change of distance. Basically, we can write speed as del d by del t. Okay, so d is basically distance, t is time, and del generally means change in distance and change in time. Okay, so del basically represents change. To make it simpler, we can write speed is equal to distance by time, or simply d by t. Okay, speed is a scalar quantity, meaning it has only magnitude and can only be positive. Okay, so let's say we take the example of speed of a car, which can be anything like 60 meter per second. Okay, and generally what we see in our speedometers is in kilometer per hour. Let's say 70 kilometer per hour, right? There is a reason why that meter is known as speedometer, because that shows only the magnitude. It does not show in which direction is the car moving. It just shows that at what speed is the car moving, and that is the reason why it is called as speedometer, right? So these are some example of speeds and different units. And always remember, the speed is always positive and it has magnitude. So this entire thing is what? Nothing but magnitude. It is no directional component. Okay, the SI unit of speed is meter per second. So as I told you, what we generally use is kilometer per hour, but the SI unit is always meter per second, and this SI unit is to be used in every numerical. Okay, another concept which I'd like to introduce is average speed. Okay, so let's say you are traveling from A to B. Okay, so you are traveling with some speed x up to this distance, and we are traveling in some speed y up to this distance, from this distance to this distance, and you are traveling in some speed z from this distance to this distance. Now, if you need to know that what is the average speed with which you are traveling in this entire journey, so what you need to do is average speed is equal to total distance, which is basically the total path length between A and B divided by the total time taken to complete this entire journey from point A to B, right? So average speed can be calculated as total distance divided by total time. Now let us know about velocity. Okay, we'll start off again with the definition. Velocity is the rate of change of displacement. So basically velocity can also be written as del x by del t. There x is displacement, t is time, and del, as I told you, represents change. Making it simpler, we can write as velocity is equal to displacement by time, okay, or simply x by t. So velocity is basically a vector quantity, meaning it will have both magnitude and direction, and it can be both positive and negative. So just like displacement, velocity is also a vector quantity, and it will have both direction and magnitude, and also for the direction only, it can be both positive and negative. Let's say uh, the velocity of a car is 60 meter per second in x direction, right? This x cap represents x direction. So if you see the difference here, the speed is only 60 meter per second, but the velocity is 60 meter per second along with a directional component. So this is very important in case of vector, because all vectors have some direction. Now, the velocity can also be minus 60 meter per second x cap. So what this negative means is that in the previous case where it was positive, the direction was in this direction, right? And now when it is negative, the car is moving in the opposite direction. This is what the negative sign means. Negative sign basically means opposite direction. That's it. Another important thing, if you note, is that velocity is what? Magnitude plus direction. So 60 meter per second along with the direction. But so this is the magnitude for velocity, right? This is the magnitude for velocity, and this is the direction for velocity. Now, if you consider only the magnitude, which is 60 meter per second, don't you think it is same as speed? Right? So what we can tell from this statement is that the magnitude of velocity is speed, and this is a very important statement. Okay, the SI unit of velocity is meter per second, which is the same as that of speed, and this is the unit that needs to be used while solving numericals. And finally, I would also like to introduce the concept of average velocity. So since we have the concept of direction now, okay, so average velocity will be what? Total displacement by total time, right? So in case of speed, we use total distance by total time, and in case of velocity, we use total displacement by total time. Rest everything is same. So let us solve a numerical now. After every topic or concept, I'll be trying to solve at least one numerical so that you can relate to the concept better and understand it. Okay. So the question goes like, Joseph jogs from point A to point B of a straight 300-meter road in 2 minutes 30 seconds. Okay. So the question says that Joseph's, let's say, start from A and jogs up to point B, which is a distance of 300 meter, right? And this is the time, 2 minutes and 30 seconds. He turns around and jogs 100 meter to reach a point C in another 1 minute. So the time taken to jog 300 meter is 2 minutes 30 seconds. As I have told you earlier, always convert this into the SI unit. So 2 minutes is what? 120 seconds plus 30 seconds, which is equal to what? 150 seconds. So basically, Joseph jogs 300 meter in 150 seconds, right? Now, it is told that he turns around from this point and jogs back to a certain point C, which is at a distance of 100 meter from this point, because he turns around and jogs 100 meter, right? So B to C will be 100 meter in another 1 minute. 1 minute basically means 60 seconds, right? So this is what the question says. Now, what it is asked, what are the average speed and velocities of Joseph from point A to point C? Now, the first question is that what is the average speed and velocity? We know that the formula for average speed is total distance by total time. Am I right? Okay. So what is the total distance here? So total distance will be the sum of distance from A to B, which is what? 300 meter, plus from B to C, which is what again? 100 meter, right? Divided by the total time. Total time is what? The time taken to go from A to B is 150 seconds, plus the time taken to go from B to C is 60 seconds. So we can say this will be 400 divided by 210, right? So you can just calculate this. It will be around 1.9 meter per second. Okay. Let us now calculate the average velocity. Average velocity. This will be what? The total displacement divided by the total time. Now, as I told you, to calculate displacement, you need to keep in mind the direction. So let this be the positive direction and this be the negative direction, right? Now, from A to B, he moves a distance of 300 meter. So here we'll write 300 meter, plus from B to C, he moves a distance of 100 meter, but in the opposite direction. So opposite direction we're considering as negative, right? So it will be minus 100 divided by, see, time can never be negative. Time is a positive quantity, and because time always moves forward, right? So the total time will be nothing but 150 plus 60. So it will be what? 200 divided by 210, right? Which is equal to 0.95 meter per second. Another way to calculate velocity is that you don't need to calculate all of this. Okay. So what we can directly do is, if the distance from A to B is 300 meter and the distance from B to C is 100 meter, then obviously the distance from A to C should be 200 meter, right? Because this is the final point, this is the initial point, and what we care is only about the distance between the final and the initial points, which is the displacement, right? So displacement will be directly 200 meters. So you can directly calculate as 200 meter divided by 210, which is what? 0.95 meter per second. So I hope you have understood the concept of average speed and velocity, and I really hope that this numerical clears all your doubts. Now let us study about uniform and non-uniform motion. So we'll start off with uniform motion. Let us first see its definition. When an object covers equal distances in equal intervals of time, the object is said to be in uniform motion. Now what does this mean? Is that, let's say a object starts from this point, right? And for every 1 second, he moves a distance of 10 meters. Then again, in the next 1 second, he again moves a distance of 10 meter. Then again in the next 1 second, he moves a distance of 10 meter, and he continues like this, right? So if equal distances are covered in equal intervals of time, then this object is said to be in uniform motion. You see, for every 1 second, he's covering a distance of 10 meter, right? So this object is said to be in uniform motion. So we'll also see what non-uniform motion is. Basically, it's opposite. So when an object covers unequal distance in equal intervals of time, the object is said to be non-uniform motion. For example, let's say the object starts at rest from this point. Now, in the first second, let's say he covers a distance of 10 meter. In the next second, he covers a distance of 20 meter. In the next second, he covers a distance of 15 meter. and in the next second he covers a distance of 5 meter, and he will keep going in this way, right? So you see now that for every 1 second interval, the distances traveled by the car or the object is not same, right? He is covering unequal distances in equal intervals of time. So this object is said to be in non-uniform motion. So I hope the difference is pretty clear. Now we are going to learn about acceleration. So acceleration is defined as a rate of change of velocity. Basically, what we can write is that acceleration is equal to del v by del t, where v and t represents velocity and time respectively, and del represents change, right? Or for simplicity, we can write acceleration is equal to v minus u by t, right? So what is v here? V stands for final velocity. U stands for initial velocity. And T is obviously time. So this is the formula for acceleration. It basically tells us that what is the rate of change of velocity, meaning at what rate is the velocity increasing or decreasing, right? Okay, so acceleration is a vector quantity, which means that it has both magnitude and direction and can be positive and negative, right? So acceleration is a vector quantity and can be both positive and negative, just like velocity and acceleration, velocity and displacement, right? So acceleration is generally denoted by A. So if the acceleration is positive, right, always remember that the velocity of object is increasing, right? So see, if acceleration is positive, meaning if this quantity A is equal to V minus U by T, right? If this quantity is positive, this entire quantity needs to be positive as well, which simply means that V should be greater than U, right? If V is not greater than U, obviously the quantity will be negative in this case. But since I have told you that the acceleration is positive, so V should be greater than U, meaning that the final velocity is greater than initial velocity, which also means that the velocity of the object is increasing, right? Let's say if A is negative, this means that velocity is decreasing. What happens in this case is V is smaller than U, meaning that the final velocity is lesser than the initial velocity, which means that the object is slowing down, right? The speed of the object or the velocity of the object is decreasing, and that is the reason why the final velocity is less than the initial velocity. So in that case, the acceleration will be negative. And there is another case where acceleration is 0. So no change in velocity or object is at rest, right? So if acceleration is 0, if for this quantity to be 0, we either have to put v is equal to u, meaning that the final velocity and initial velocity are the same, right? There is no change in velocity. Or let's say v is equal to 0 and u is equal to 0. U is equal to 0, v is equal to 0 simply means that the object is at rest. Because if the initial velocity is 0, means the object has not even started moving, right? So A is equal to 0 in the case when velocity does not change or the object is at rest. I hope this point is clear to you. And the SI unit of acceleration is what? Meter per second square, right? Now, I have explained all these terms to you. We'll just dig into some numericals so that you can understand the concept in a better way. So now we're going to solve a numerical on acceleration. The question says that a vehicle is accelerating on a straight road during a particular time interval of 10 seconds. So we have our time here, which is 10 seconds. The vehicle was initially moving with 10 meter per second. So as I told you, u denotes initial velocity. So u will be what? 10 meter per second, and reached a velocity of 30 meter per second at the end of the interval, meaning that v, which is the final velocity, is equal to 30 meter per second, right? So the question asked you to calculate its acceleration. So we know that the formula for acceleration is a is equal to v minus u by t, right? So just put all the values that are given in the question. So v we have 30, u we have 10, and t we have 10. So basically it is 30 minus 10, which is 20 by 10, which is 2 meter per second square. As we can see here, the acceleration is positive, meaning that velocity is increasing, right? Because the final velocity is greater than the initial velocity. So the velocity is increasing. So I hope you have understood the topic acceleration, and also we have learned how to use it in numericals. Moving on to uniform circular motion. So uniform circular motion basically means that an object is traveling in a circle, right? So there are some key points which you need to understand in case of uniform circular motion. First, the word uniform means here that the speed is constant. Okay, so this is the first and foremost point which you need to understand, is that the speed is constant. Next, the velocity is constantly changing. So even if the speed is constant, and we know that a magnitude of velocity is speed, but the velocity isn't constant because the direction of velocity is changing at every point of the circle. The direction of velocity here is tangential at all points. Now, if you don't know the meaning of tangential, so let me just make you understand in brief. So if this is a circle, let's say, and this is the radius, right? So at this point, we'll draw a perpendicular line which is perpendicular to this radius, right? And touching the circle at only a single point. So this particular line is called a tangent. So at every point on the circle, let's say if the object is at this point, then the direction of velocity is always tangential to that point, right? So this is the direction of velocity. If let's say the object is at this point, then the direction of velocity will be in this direction. Let's say if the object is here, the direction of velocity is in this direction. And if the object is here, the velocity is pointing in this particular direction. So you see that at every point on the circle, the direction of velocity is changing, and hence it is told that velocity is constantly changing, right? Now, uniform circular motion is an accelerated motion as well, meaning that if velocity is changing, meaning if velocity is not constant, obviously there will be acceleration, because we know what acceleration is, basically rate of change of velocity, right? Rate of change of velocity. So if velocity is changing, then obviously there will be acceleration. Now, what kind of acceleration is present in uniform circular motion? There are basically two kinds of acceleration. First of all, there is a radial inward pointing acceleration, meaning this acceleration is pointing radially inwards. Radially inwards meaning that it is pointing towards the center of the circle, right? So this acceleration is known as the centripetal acceleration. Centripetal acceleration. Now you might be thinking that if it is undergoing circular motion and there is an acceleration towards the center of the circle, then why does this object does not directly fall to the center? Because there is a balancing acceleration as well, which is radially outward. So this acceleration is acting exactly opposite to that of centripetal acceleration, and this acceleration is known as centrifugal acceleration. So centrifugal acceleration is an advanced topic and you would be studying in your standard. But yes, you need to remember that there are two kinds of acceleration that are acting on the body while undergoing circular motion. Is that we have centripetal acceleration and centrifugal acceleration, right? So uniform circular motion is an accelerated motion. And finally, the formula for speed is, we know speed is equal to what? Distance by time, right? Now, in this case, the distance is the entire circumference of the circle. So it will be what? 2 pi r, if r is the radius of the circle. And we have here our time, right? Which is t. So the speed in case of circular motion is 2 pi r by t, where r is basically the radius. So I hope you have understood uniform circular motion as well.